Okay, Mr. Hong here with another video. Just like a half lecture, half video kind of thing for 5-9. And this is going to be talking about something you've never learned before, but we're going to be using pre-existing knowledge, such as certain things to help us figure out how to do something new, kind of like everything else in the class. So 5-9, complex numbers. First, I want to talk about why we even do this. And for us to be able to know why we do this, we have to define what a complex number is. A complex number is a real number plus or minus an imaginary number. Plus or minus imaginary number. Looks something like this. 4 plus 3i. Sure. And you don't even know what this is yet. But for me to introduce this topic, I need to first define what even an imaginary number is. So an imaginary number is equal to the square root of -1. So it looks very similar to this. As in, I tell you what I is equal to. In the world of geometry, or in the world of math, I guess, in general, we know that we always put the variable after the coefficient. As in, for example, the coefficient of my I, if it was like 3x, this would be the coefficient, and this would be the variable. So we're going to write it very similar, kind of like with the I. We're going to treat I very similar to a variable. I is equal to square root of -1. And why that is important is because if I take the square root of -49, if I put this into the calculator, it's going to be not like you can't do it or no solution. So the way that we combat that in calculus, algebra 2, whatever, and math in general, we have to take out the I because we're not allowed to. That's a J. There's an italic I, kind of like a backwards J. We have to take out the I to take away this negative sign. Because, 7 times 7 is 49. This is a positive 49. -7 squared is also positive 49. So, nothing squared can equal -49. So, if I take out the negative sign inside of my square root, then it's a problem that I can solve. And this is I times square root of 49. And this turns into, which I will put now in the front, because this is a whole number 7, and the I will come after the coefficient. So that's really the idea behind imaginary numbers, and we're going to be talking about complex numbers very soon. So for any possible number, let's say A, these are the series of steps that we can do to get our final answer. For example, I can do square root of -1 times A. As in, I can split this up into two pieces, right? Kind of like how I have a -7. I can say that it's -1 times 7. Sure. You're allowed to do that. So if I can do it with numbers, I'm allowed to do it with variables as well. Okay, so I know that in square roots, I can split it up, kind of like this. Square root of -1 times square root of A. As in, all I did was split this up into two pieces. So I guess this arrowhead isn't really accurate. It should turn into like this. And like I said before, the square root of -1 is I. And the square root of A, it'll stay as square root of A. Sure, we don't know what A is, but if I did know, then we could move further. So I can rewrite all of this as I square root of A. And this is the time where you would just leave it like so, because the square root icon is not really good looking. Oh, you can't really even see this because of my video. There you go. Kind of like that. So if it's a whole number, it goes in front. If it's a square root, it goes in the back. So I'm gonna. Oh, I even wrote it right here in this box right here, just in case you didn't want to know. I just skipped the steps. So knowing that or trying to understand that, let me do an example for you. For example 1, write the square root of -9 as an imaginary number. So what that really means is, okay, we can split this up into pieces. So square root of -9 is equal to, kind of like how I had this negative a, the square root of negative a. Oh, hold on, just a moment. Okay, so when we take the square root of -9, we're gonna have to first take out. Well, hold on. Okay, we're gonna have to take the square root of -9. So what we have to do here is, what is going on with my pen? Hold on. Is this one? Nice. It is this one. So we can split this up into two pieces. We can make this -1, and we can have it multiplying to +9. So the objective here is to say that, okay, I can take a square root of a positive. I know. Yeah, man, you can go. Take the pass with you. I know that square root of -1 is equal to I. You also know square root of 9 is equal to 3. So this can become a 3. This becomes an I. And now we have to rewrite it to make it look aesthetic. Or make it look nicer, I guess. So this is 3I is equal to square root of -9. So really, this is the most appropriate thing you need to know how to write. The reason why I wrote the square root of -9 is because this is the question right here. So not too shabby. The question is easy. Well, for me, it's easy because I know that -9 is going to turn out to become like really nice and clean. So try to do example 2, where a number, if you take a square root of it, you'll have a nice and clean number as well. So I'm going to wave my hand to predict that I am going to. Hold on, give me another moment. All right, so yeah, try this problem out yourself. And I'm going to wave my hands to make sure that I make this a question Edpuzzle. This. Okay. So hopefully you did it. Let me just do it real quick. Square root of -25. This can turn into square root of square root of -1 times square root of 25. I know that this turns into I, and I know that the square root of 25 is 5. Or 5 squared is equal to 25. So square root of 25 is equal to 5. So now all I gotta do is rewrite this as 5I. So these are pretty nice. They turn out pretty nice and easy, nice and clean. But what happens if I have a number like example 3, where it isn't a perfect square? So what do I do here? And really, the best way for you to do is think about splitting this question up into pieces. As in, we split up this -9 into pieces like so. So if I can split up this -8, I can split it not only to 2 pieces, but also to 3 pieces or even 5 or whatever. So if I have square root of -8, let's say, for example, I want to make it into 2 pieces. Well, the first piece will have to be the -1, because I can't do anything with -1 as my, like, inside my square root. That's something I have to accept. You must take out a negative. The other part is square root of 8. And there's no perfect square for square root of 8. There's no right answer. Kind of like the 9 or the 25. It was clean. But what I can do with the 8 is I can do another factor tree. As in, I know that my perfect squares are 1, not 2. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and so on and so on. So if I can look at any of these numbers, okay, I know that I can divide this 8 by something and 4. 4 is a perfect square, and I'm gonna reach out to get this 4. Because I know that this 4 will turn into a positive 2 without a square root. So 4 times something has to equal 8. That must be 2. And the square root of 2, we're just going to leave it as square root of 2 because there's nothing else smaller, or there's no way for me to simplify square root of 2 any further. So what happens is that, I'm going to rewrite this now because it's kind of messy. So it becomes negative 1, I have a square root of 2, and I have a square root of 4. Sure. We know that this turns into I, and I know that this square root of 4 turns into a regular 2 without the square root. Very similar to what happened up here. My 9 or square root of 9 became a positive 3 without a square root. That's my goal. And like I said before, this square root of 2, I cannot simplify it. So I'm going to leave it the same. So if I want to rewrite this nicely, it always goes in order of whole number, imaginary number, square root of 2. Like so. So really the skill for you as Algebra 2 students is that you need to be able to memorize all your square roots or have it next to you, just so that you can prepare yourself to divide evenly into a perfect square so you can evenly square root into it. Lots of words, but once you apply it, it's very simple. I'm going to give you guys time for you to do example 4 by yourself as well in the Edpuzzle. So I'm going to wave my hand again to signal that I need to put a question here because I don't like watching my videos. It's weird listening to my own voice. Okay. That was enough time. So if I want to take the square root of negative 45 and I want to split it up into pieces, well, the first piece, I have to take out a negative 1. And that means that this has to be 45, a positive 45. So if I keep doing another factor tree, if you didn't notice, kind of like how we factored, the factor tree, I want to make this a number of a perfect square. I'm going to just draw a square, a perfect square. So can 45 be divided by 4, or can 45 divided, can it be 9, or can 45 be divided by 16? Yeah, it can be. And the real answer should be, for you, or you should have hopefully figured out, right here. This is the one that we can do, because a 9 is divisible. So this is square root of 9. So this is equal to 5. So my other term, or my other square root, is going to be 5. As in 5 times 9, 5 times 9 is equal to 45. So now I have 3 things that I can do to make my imaginary number. Boop, boop, and boop. So let's write that on the side to just clean it up. I don't want this factor tree anymore. I've got all the fruits that it can bear. Negative 1, square root of 5, square root of 9. I know that this becomes I. I know that this becomes 3. I know that this thing, square root of 5, is not a perfect square. 5 is not a perfect square. As in, number squared does not equal into a 5 nicely. As in, this number right here is not whole. So it'd be counterproductive for me to write decimals after decimals for me to just simplify that. It's just nicer for us to write it as square root of 5. So look, the order is whole number, then imaginary number, then the square root of 5. So I'm going to write that nicely here. Oh. There we go. So yeah, not too bad. 15 minutes. I'll just do this a little bit more so I don't have to explain it in class. So complex numbers, like I told you, is a combination of imaginaries and real numbers. And kind of like what we learned so far in this video, this part is the things that we find right here or here. Oh, like our final answers in the questions above, these are my imaginary numbers because they contain an I. So this must have an I, or also known as imaginary. And this part is real, as in this is a regular whole number or decimal. Whole decimal, or even like a fraction. Sure, as long as it's a real number. So if you remember from like 5th grade, which is a long time ago, even Mr. Hong confuses this, but complex numbers contain both real numbers and pure imaginary numbers. So really we add this plus or minus sign here to combine these two to create a complex number. So example 5 is going to be the last thing I talk about in this video. So example 5, write 7 plus square root of negative 36 as a complex number. First I have to do another factor tree, and I have to take out the negative 1. That is the reason why we're learning this. And what comes out, well, the other factor is 36. And the square root of 36, if you didn't know, is 6. So the 7 I did not touch. This turns into an I. Remember, we write the 6, the whole number, before the variable or the letter. As in, this is the coefficient, kind of. And this is the variable, kind of. Kind of. The behavior is very similar. So I would write it like so. All right, we're gonna meet up back in class. It's been about 18 minutes since I started the recording, so I'll see you guys back in the video or in the video chat later.